Hello everyone! It's me again, Teacher Joanne. This tutorial is for Statistics and Probability, a subject which is intended for grade 11 senior high school students in the Philippines. For today's objectives, at the end of the lesson, the learners will be able to convert a normal random variable to a standard normal variable and vice versa. Computes probabilities and percentiles using the standard normal table. For today's topic, we have standard normal distribution. So, as stated earlier, any normal distribution can be transformed into a standard normal distribution by the formula where mu equals the mean and the sigma equals the standard deviation. So, the formula is z equals x minus the mean divided by the standard deviation. Or, if we have two values of x, so we have x sub 2 minus the mean divided by the standard deviation minus x minus mean divided by the standard deviation. So each of the values obtained using the given formula is called a z-score or the standard score. So z-score tells us how many standard deviation a value is away from the mean. So a negative z-score tells that the value is below the mean, while a positive z-score tells that the value is above the mean. A z-score is unitless, thus even values of different units could be compared relative to their groups. So now let's have an example. So example number 1, let x be a random variable with mean equals to 5 and variance equals to 4. Find the following probabilities. A, probability of x is less than 3. B, probability of x is greater than 2.5. Then C, probability of x is greater than 7.2 but less than 7.5. So let's start solving for A. Probability of x is less than 3. So to solve, we use the formula z equals x minus mean divided by the standard deviation. So since our given is variance and we needed a standard deviation, we just needed to get the square root of the variance. So that could be 2. And then we substitute the values. So x is 3 minus the mean, which is 5, and then divided by the variance, which is 2. So 3 minus 5 divided by 2, so that is z equals to negative 1, which is equivalent to 0.1587 if we look it up on the ztable. So next we have letter B, probability of x is greater than 2.5. So we'll be using the same formula and then just substitute. So 2.5 minus 5 divided by 2. So that will be negative 1.25, which is 0.1056 if we look it up on the z-table. But that is not yet the answer. So if you remember, so we have a greater than symbol. So we needed to subtract the area that we look it up from 1. So we will have 1 minus 0.1056 is equal to 0.8944. So probability of x is greater than 2.5 is 0.8944. Next we have, find the probability of x is greater than 7.2 but less than 7.5. Okay, so we'll be using the other formula since we have two x's. So we have x sub 2 minus mean divided by the standard deviation minus x sub 1 minus mean over standard deviation. Then just substitute the value, so 7.5 minus 5 divided by 2 minus 7.2 minus 5 divided by 2. So we would have 1.25 minus 1.1. So for this one, we will not be subtracting the two values. First, what we have to do first is to look for the value of 1.25 on our z-table and then 1.1 on the z-table as well. So we would be having the 0.8944 minus 8643. So the probability would be 0.0301. So example number 2. So the scores of a group of students in a standardized test is normally distributed with a mean of 60 and standard deviation of 8. So what percent of the students got below 72? What part of the group scored between 58 and 76? Then if there were 250 students who took the test, about how many students scored higher than 64? Letter A, what percent of the students got below 72? So to write that, so we will be looking for the probability of x is less than 72 since we have there below 72. So we're using the formula z equals x minus mean divided by the standard deviation. Then just substitute the values. So we have 72 minus 60 divided by 8. So we have z is 1.5. And if we look it up on the z-table, so that would be 0.9332. So since we're looking for the percent, so just multiply that by 100%. So therefore, about 93.32% of the group got below 72. So to solve for B, so what part of the group scored between 58 and 76? So just rewrite that. So we will have probability of x is greater than 58 but less than 76 since we're looking for the between score. So the formula, so we have z equals x sub 2 minus mean divided by the standard deviation minus x sub 1 minus mean divided by the standard deviation. And then we just have to write that. So 76 minus 60 divided by 8 minus 58 minus 60 divided by 8. So we would have 2 minus negative 0.25. So that would be, so the value of 2 on the z-table is 0.9772. And then the value of negative 0.25 is 0.4013. So just subtract the 2 and we will have z equals 0.5759. So therefore, about 57.59% of the group got a score between 58 and 76. Then for letter C, we have if there were 250 students who took the test, about how many students scored higher than 64? So to write that, we have probability of x is greater than 64. So because we're looking for higher than 64. Okay, so just use the formula z equals x minus mean divided by the standard deviation. And to substitute, we have 64 minus 60 divided by 8. So we will have 0.5, and on the z-table, that is 0.6915. So the area above is 1 minus 0.6915. So since we're looking for the above score, so we're subtracting that from 1. So we would have 0.3085. So since there were 250 students who took the test, so just multiply that 0.3085 by the number of students who took the test. So we will have 77.13, and our final answer is 78 students got a score higher than 64. So why 78? So since we have a decimal part and we're looking for a student, so that's a discrete variable, so we just have to add 1. So that 0.13 is considered as 1. That's why the answer is 78 students. And example number 3. A highly selective university only admits the top 5% of the total examinees in their entrance exam. The result of this year's entrance exam follow a normal distribution with a mean of 285 and a standard deviation of 12. So what is the least score of an examinee who can be admitted to the university? So for the solution, we have the probability of Z is greater than A equals 0.05. So the 5% is the 0.05. So this means that 5% are above this. So since it says above, we subtract the 0.05 from 1. Then we locate the difference, so the 0.95 on the z-table, and we will have 1.65 for the value of A. Then now we can solve. So we have the given Z. So that's 1.65 equals X. So the X is the one we're looking for, or the score. Then minus the mean, which is 285, and then the standard deviation is 12, so divided by 12. So solving algebraically, so we will, by cross multiplication, we will have 1.65 times 12 equals X minus 285. So then we will have 19.8 plus 285 equals X. So X would be 304.8 or 305. So therefore, an examinee should have at least a score of 304.8 or 305 to be admitted to the university. Okay, so we're done for today, and thank you very much for your time. I hope you learned a lot today. See you in our next lesson. Bye!